Hey y'all, we're going to talk about angles a little bit more here, and we're going to talk about angle addition, which is very, very similar to segment addition. Instead of segments, we'll be talking about adding angles. So the first thing we'll do is we'll talk about this postulate, the angle addition postulate. Very similar again to the segment addition postulate, where we're adding two smaller angles to make one big angle. So we have three angles in this picture. The first angle we have is angle ABD. That's this angle that's formed by ray BA and ray BD. And remember that I use this little curve with an arrow on the end to show which angle I'm talking about. We also have ray DBC, formed by ray BD and ray BC. And we use our little arrow. Sometimes I could fill it in if you want to get creative. And those two angles share a common ray. They share ray BD. So they kind of come together and they make one big angle, angle ABC. So we're talking about this entire big angle. And that's formed by putting the two smaller angles together, as you can see. So ABC is formed by ray BA and BC, and it's the sum of this smaller angle DBC and this smaller angle ABD. So if we knew the measures of all those in degrees, we could add angle ABD to angle DBC, and it would give us the measure of the entire angle, angle ABC. So it's very similar to segment addition, where we took two smaller segments, put them together, and they added up to be the entire length of a segment. So we can use the angle addition postulate with a little bit of algebra, and we can find some measures of angles. So at this point, pause the video, try this example on your own, and then we'll go over the answer together, and you can check your answer. So we're told that the measure of RQT is 155 degrees. So let's look at RQT. It's the big angle. It's this whole thing. And that's 155 degrees. And then we can see that RQS is 4x minus 20, and TQS is 3x plus 14. So we can write a equation using our angle. So if we add the two smaller angles, they add up to be the entire big angle, and that's what this equation represents. And now we just need to plug in what we know. So plugging in what we know, we get this equation, and once we get to this point, it's good to substitute with parentheses, but since there's a plus in between here, nothing's going to change as far as the signs go. So you can get rid of your parentheses if you want to, and then we can combine like terms on the left side. Be sure to be careful here. Minus 20 plus 14 gives us a minus 6 here. And the 4x plus 3x gives us a 7x, and then we can finish solving this equation for x. So if you finish solving the equation properly, you should get x equals 23. And as always, make sure you answer the question that's being asked. So if we go back up to the question, we are looking for the measure of RQS, angle RQS, and the measure of angle TQS. So we're not quite done yet. We need to take x, and we'll plug it back over here into these expressions, and we can find the actual measures of the angles we're looking for. So we should get the measure of angle RQS is 72 degrees. And we'll finish by finding the measure of SQT, or TQS. And we end up with the measure of angle TQS being 83. And in order to check our answer, both of those should add up to 155. 72 plus 83 is 155. So the two little angles add up to be the big angle. Another piece of vocabulary here, talking about an angle bisector. This is sort of like a midpoint where it divides an angle in half, just like a midpoint divided a segment in half, into two congruent parts. So we have a big angle, LMN. That's our big angle. And we know that the two smaller angles, LMP and PMN, should add up to be LMN. And this ray MP, is an angle bisector. That means it cuts LMN in half. So to show that two angles are congruent, we can do arcs here. I don't have the arrows, so these arcs are telling me that angle LMP and angle PMN are congruent. And we use our congruent sign again, just like we did with segments, when congruent segments. So this says that angle LMP is congruent to angle PMN because ray MP is an angle bisector, and so that these two angle values will be equal. So perhaps one is 30 and the other one would be the same, would be 30 degrees. So two equal angles. So pause here, try and find the measure of angle CAB and the measure of angle DAB. Make sure to note the symbols in the picture, and that'll help you. So you should notice, because of these two red little angle symbols, these two angles are congruent, DAC and CAB. That means that ray AC is an angle bisector, and these two angles should be congruent, which means they're equal. So we can say that the measure of angle CAB is equal to the measure of angle DAB, and if angle DAB, I'm sorry, this should be angle DAC, so the two small angles, DAB is the entire angle. We still want to know how big it is, but that's the big entire angle. So CAB is equal to DAC, and we know that DAC is 58 degrees from the picture, so that means that angle CAB is 58 degrees. And we know from angle addition that these two angles should add up to be the entire big angle, angle DAB. So that means the measure of angle DAB is the sum of the two smaller ones. So we just add 58 to 58, and we can get 116 degrees. So there are our two answers. Okay, I want you to try these two questions using your notes and using the examples from the lesson, and be sure to submit your answers online, please. The link will be in the description section of this video below. Good luck.